Question 3, and I'm on to static moments. I've got a non-uniform rod, so we know its centre of mass is not going to be in the centre of its length. It's resting on a rough floor and against a rough wall. So I can start adding some information here. So I know that the floor is rough, so I'm going to need something to do with the reaction force at the floor. I also know that the wall is rough, so I know that I'm going to need something to do with the reaction force at the wall. Now these are likely to be different values, so let's call this one N and the other one R. We also know that the rod is on the point of slipping at both ends, and because it's on the point of slipping, then friction will take its maximum value. Now, if the ladder were to slip away, it would move away from the wall, which tells me that friction must be acting in towards the wall. So here I have F max, which is going to be equal to the coefficient of friction, which is 1/4 of R. Now at the other end of my ladder, if it's slipping away, it would slip down the wall, so friction must be acting up the wall. And again, it's going to take its maximum value, and my coefficient of friction here is 2/3, so this becomes 2/3 of N. The only other thing that I'm missing, I don't really know where to place it, so let's just pocket here for the time being, is going to be the weight of the ladder itself. Now we're told that it has mass m, so this here becomes mg. For the first part of this question, I'm looking at finding the magnitude of the vertical component of the force exerted on the rod by the floor. So that is going to be our R value. So for the first part of this question, we're going to want to find out what R is. Now we can do that very neatly if we just go back to our diagram, and first of all we're going to resolve vertically, I think. Because if I resolve vertically, I know that R plus 2/3 of N will be equal to mg, and after resolving vertically we will resolve horizontally, and we'll find out that 1/4 of R will be equal to N. Now I can use both of these pieces of information and substitute for my N value in my first equation so that I can eliminate it and end up with something only involving R. So this will become R plus 2/3 of N, and we know that N is 1/4 of R, and that will be equal to mg. This becomes R plus, I can cancel a 2 here and a 2 here, so this becomes 3 times 2, which is 1/6 R, which is equal to mg, and R plus 1/6 of R will be 7/6 of R, which is equal to mg, and finally R will be equal to 6/7 mg. For the second part of this question, I'm looking to find the centre of mass of the rod, and we want to know its distance from A. We want to know the distance A to G, so this point on my rod I now know to label G, and what I'm really interested in is my distance A to G. Okay, so to do this we're going to take moments. Now as always, it doesn't really matter where we take moments about. I say it doesn't really matter, it doesn't matter at all. We can choose any point. We could choose the point A, we could choose the point G, we could choose the point B, or we could pick a point that doesn't even belong to the rod, like a point up here which is called P. I have no idea why I enjoy doing it from the point that's not on the rod, but I certainly do, and here we have moments at P. If I take moments at P, then immediately I don't need to concern myself with my vertical force here, R, or my horizontal force here, N. What am I left with? Well, let's think about clockwise being equal to anti-clockwise. All of my moments that are clockwise from this point are going to be my mg, and the distance that is from my point P is going to be, well, let's call this distance here x, so that becomes x cosine 60 multiplied by mg. Now acting in the opposite direction is going to be the force that I've got at the top here, which is 2/3 of n, and that is acting at a distance of 2l multiplied by cos 60. So sort of the whole length of this is 2l cos 60. And the other thing that's acting in my anti-clockwise direction, so I need to add on to that the quarter of r at the bottom, and the distance that is from my point P is going to be 2l sine 60. Now from this point it's just a case of working through the algebra, so let's go through this nice and clearly to make sure that we don't make any mistakes. Cosine of 60 I know is a half, so I can simplify the left hand side to say that's x multiplied by a half of mg. On the right hand side I've got 2/3 of n. Now we knew from earlier in our question when we resolved that n was a quarter of r, so here I want 2/3 of a quarter of r multiplied by 2l multiplied by cosine of 60, which is a half, and then to that I need to add on 1/4 of r multiplied by 2l multiplied by sine 60, which is √3/2. Leaving my left hand side as it is, that's x multiplied by a half mg, which is going to be equal to, we have a value for r which we found out in the first part of our question, which was 6/7 of mg. So tidying this up ever so slightly, I recognise here that I'm going to get cancellation between my 2 and my half, and a little bit of cancellation here to leave me with 1/6 of r, which was 6/7 of mg, times by l, and then the other part is going to be 1/4 of r, which was 6/7 of mg, and again I've got cancellation here between my 2 and my half, so that's multiplied by l √3. I now notice that mg will cancel everywhere, so let's also take this opportunity to multiply by 2. So I'm going to multiply through everything by 2 and also divide by mg to find out that x is going to be equal to 2/7 of l plus, what have we got here, multiply by 2, this should be 3√3/14. 3√3/7. Where's my maths going? 3√3/7 multiplied by l. So now I can factorise and say that this is 2 plus 3√3 multiplied by l/7. Or I suppose we might prefer to keep our numbers together, so let's pop our l at the end and pop all of this over 7. Pop that into a calculator to find out that x is equal to 1.03 multiplied by l.